Hello everyone. I am Dr. V.V. Kamesh, Professor of Mechanical Engineering, Aditya Engineering College, Surampalam. In today's class, we will discuss about simple vertical boiler as an example, Cochran boiler. The learning outcome of this class is at the end of this lecture, you will be able to explain the working principle of Cochran boiler. And to get acquainted with the vertical boiler or horizontal boiler, like different classification of the boilers, initially we need to have a fundamental understanding of what is fire tube boiler and water tube boiler. Because in one type of boiler we are using fire tube, another type of boiler we are using water tube. Okay. So basically the fire tube means, as earlier we discussed about this, fire tube means fire will be in the tube. So fire means here the exhaust gases or burnt gases or some heat, right? So fire tube means just like in the screen, whatever you are seeing. So there is some shell. So furnace will be here. So from this furnace, the gases will go along with the tubes and they will go out. The hot gases go out through some chimney. So in between, these tubes are being surrounded with the water, and the water gets heated and it is converted into the steam, and water will enter into the shell in one side and the steam will go out in another tube. Okay. So this is called fire tube. Similarly, water tube boilers. So fire will go in one way and water will go through the tubes, right? So the water tube boiler means water will be inside the tube. So while passing through the tubes, due to the excessive heat transfer, the water inside the tube will get converted into the steam inside the tube itself, and it will go out through another tube outlet. Okay. So this is fire tube and water tube. Now coming to our vertical boiler. So any vertical boiler you can see, it will occupy less space and the furnace will be placed inside the boiler shell. So to get the space advantage, boiler shell will contain the fire and the water is also in the boiler shell. So either the tubes, it may be fire tube or water tube, whatever it might be, in the vertical boiler, there will be place advantage. Okay. So the combustion gases, after heating the water and thus converting it into steam, escape to the atmosphere, as earlier we discussed. And the rate of production in a vertical boiler, it doesn't exceed 2,500 kgs per hour, and pressure is normally limited to 7.5 to 10 bar. That means low pressure. Okay. Now, as an example of simple vertical boiler, we will discuss about the Cochran boiler, and it is one of the best types of vertical multi-tubular boiler. In earlier our discussion about the classification of the boilers, single tube and multi-tube. So Cochran boiler is multi-tubular boiler. So many tubes are available here and has a number of horizontal fire tubes. Okay. And Cochran boiler consists of a cylindrical shell with a dome-shaped top where the space is provided for the steam. And the furnace is a one-piece construction and it is seamless. So it is continuous. Seamless means continuous. Its crown has a hemispherical shape and thus provides maximum volume of space. And the fuel is burnt on the grate and ash is collected and disposed of from the ash pit. So we'll see part by part in the diagram. Okay. So this is a simple line diagram of your Cochran boiler. You can see so many parts in the bottom. You can see ash pit, and here the furnace. There is some coal or some fuel is there. So there are some burnt. So burnt gases. You are seeing the arrows. They are going upside, and through the tubes, it is going through outlet in the form of chimney. So while starting with the furnace coal point to the flue gases through the tubes, so it is being surrounded with the water. So automatically the water will be gets converted into the steam, and the steam will go through the hemispherical top outlet. Okay, so you can visualize so many other parts, as earlier we discussed about boiler mountings and accessories. So different mountings and accessories like chimney, smoke box, fire hole, ash pit, safety valve, manhole, water level indicator, steam stop valve, so many things, right? We'll discuss part by part in the next diagram. Okay. So this is a somewhat colorful diagram. Uh, so starting from the genesis, will come like this. Okay. Now you can see, without seeing the outer parts, just to look at only the hemispherical part and the cylindrical part. So think that there is no other parts are being enclosed. You are having a cylindrical shell and it is covered with hemisphere. Okay. At the bottom, there is a furnace. There is a grate. So there we are placing the fuel, and the fuel is being burnt, and there is a place for fire door. So look at the bottom right side. There is a grate, and after the firing, definitely there will be some ash. So there is some ash pit to collect the ash, and this is the fire door and grate, and the boiler shell is obviously there. Now, after the flue gas are getting ready, there need to be some pass through the tubes, right? So there is a flue pipe arranged here, and the pipes, that means flue gas pipes, there are some, here it is given the 4 pipes, and you may have some five pipes or 10 tubes, whatever you like. Okay. And these pipes, they are passing through a smoke box, and smoke box next level, it will go to chimney. And there is some door, right? Always you are having some facilities to remove the ash, to remove the boiler scale, and to remove some smoke, to remove some condensed water, right? Condensed steam converted to water. So like this, always you are having some facilities to remove the excess items which are not necessary for the boiler operation. So here there is a door to remove the some smoke to go out. Okay. And finally, it is going through chimney. And there is a fire brick lining. So inside the boiler shell, we are having fire brick lining. So why we are having the fire brick lining? Not not to have the heat to go out. So the heat transfer rate should be very low, right? Here the heat transfer means from flue gases to the water, heat transfer rate will be very high, but fire brick lining will make as an insulation so that your entire heat generated inside the boiler shell will be inside only, okay, to the maximum, right? And in the next diagram, you can see all items of your Cochran boiler. So at the bottom, we are having the coal fire or the fuel fire, and the gases will go through flue pipe, and the pipes you are seeing some peach color here, and through smoke box, the gases will go out. Now, in between, inside the boiler shell, we are having the water. So now you are looking here, some dotted lines up to the bottom. Up to the bottom, it is completely filled with the water, right? So all the dotted lines, you are seeing the water, and there is a left side, you are having water level indicator, right? And your fire brick lining by the side, you are having fusible plug. So what is the purpose of the fusible plug and everything? Already we discussed earlier. Fusible plug means if any damage is inevitable, the fusible plug will save the boiler not to have explosion. Okay. And there is water level indicator, feed check valve, and manhole for the inspection, pressure gauge to record the pressure inside the boiler, how much pressure of the steam is being continuously generated. And there is some anti-priming pipe here. You are looking at the top side of the hemisphere, and to the effects of your boiler, you are having steam out. So there we are having steam stop valve, and to the right side of your hemisphere, deadweight safety valve is there. I told you earlier, there is a slight difference between the stop valve and safety valve. Safety valve is for the prevention of the explosion, and stop valve means we are making the steam to go out or to be entrapped inside. So this is stop valve is different, safety valve is different. Okay, and finally the chimney, right? So the boiler shell, door, fire door, grate, ash pit, all these are your boiler integral parts like mountings or accessories. Okay, and characteristics of your Cochran boiler is it is vertical, and as you are seeing, the fuel is burnt inside. It is internally fired, and it is naturally circulated boiler. That means the water once get in contacted with the fire tube, automatically the density will become less and it will go to the top side. So the high dense water, that is cool water, will come automatically to the downside, and you are looking at the downside, we are having intimate contact with the fire tubes. Okay. So these are all the different operations. You can see how the water is moving, how the steam is being collected at the top side, and it is going out through steam stop valve. And the specifications, so for any boiler, we are having some specifications, right? So here, the Cochran boiler will have shell diameter 2.75 meters, and height will be 5.75 meter, and heating surface area 120 meter square, and working pressure will be 6.5 bar, and steam capacity, the generation of the steam will be 3,500 kgs per hour, and efficiency of this boiler will be very high, 70% to 75%, right? And the working, so what is the first stage, what is the second stage, like this, right? Initially, the water is supplied to the boiler through feed check valve. Now you can see to the top left side, you are having feed check valve. So first we need to confirm that the water passage is getting ready, and then the water will go inlet, and the coal is introduced to the grate through the fire door. So at the top side, we are making the water to enter the shell, and from the bottom right side, we will open the fire door and we will make the coal to enter into the grate. And the hot gases after the burning is over, after the combustion is over, the the hot gases will enter the combustion chamber through flue pipe, and they will enter into the horizontal fire tubes. Now the heat transfer will take place from the flue gases to the water. Okay, so it is by the convection process. So convection means from one fluid to another fluid through the surface contact. Okay, so the flue gases coming from the fire tube enters the smoke box and then finally discharge through atmosphere through chimney. And the ash formed by the combustion is collected in the ash pit. The steam is collected through anti-priming pipe on the top of the shell. Well, we discussed earlier, the purpose of this anti-priming pipe is to remove any water particles that are existing in the steam, because we want to have dry saturated steam to hit the steam turbine blades. Okay. Now the advantages and some disadvantages or limitations of Cochran boiler are, the advantages are it is compact and it is portable boiler. So minimum floor space or the floor area is required, and initial cost is also less, and it can be moved and set up readily in different locations, and quick and easy installation, Of course, this point is almost linked with the first point because it is portable. Installation is also very easy, and any type of fuel can be used. So not only coal, you can have some other fuel also. And the disadvantages, it is actually low pressure boiler. So steam rising capacity is less due to vertical design. So whenever your area of contact or area of the heat transfer area is less, automatically it is limiting your steam raising capacity. And water along with the steam may enter the steam pipe under heavy loads due to small steam space. You can look at the diagram. At the hemispherical area only, we are having the steam generating area. Okay, so there may be some entrapment of the water to enter into the steam pipes. So that's why we are putting anti-priming pipes. And efficiency poor in the smaller size. Unless otherwise you are having the size is very big, we can't have uh, 70 to 75% efficiency. Okay, so this is regarding the Cochrane boiler, and you learned from this lecture the characteristics of a vertical boiler and working principle of a Cochrane boiler, advantages and limitations. Thank you very much.